good morning, people. You already know who I am. I think we'll say at this point that our purpose here is not to prove whether or not this project happened. What we are here is to discuss what they did, how they did it. Mr. Billick already discussed very well what they did. So we'll go into the meat of it. Essentially, the Montauk project was a very large mine amplifier. That's essentially all it was. I have here a very simplified block diagram.
Get back up on the platform and get you.
Well, the trouble is I'm having trouble seeing the diagram.
Okay, go ahead.
I can be right here. All right. Very simplified was essentially a transmitter. We had an input network, which was the Montauk chair, that's what we called it. Mr. Cameron, sitting over there in the red shirt, was the psychic that sat in the Montauk chair and fed information into the computer system. The computer system essentially processed the information and spit it out to the transmitter. We had two transmitters, drove one of two antennas. There was also a Delta T antenna and a 100 kilowatt noise amplifier. This was the basic outlay of the Montauk system. Nice feedback. We will first discuss the Montauk chair. There was two versions of the Montauk chair. The Montauk chair was developed by ITT, World Communications, or the government, or whoever developed this project. The chair had essentially three coils in it. You can see the Y coil went like this under the floor, formed two sides of a pyramid, came out. Another coil came up, formed the other two sides of the pyramid, came out. The third coil was essentially two coils, one on the floor and one on the top. These provided three outputs of essentially an RF signal. The signal looked like white noise, essentially. But the correlations in the white noise was the information of what the person had in his mind sitting in the center of the pyramid. I have to apologize for my drawing. It isn't all that great. This should be right under the point of the pyramid. And the receiver system looked essentially like this. You had your three loops. You had your three basic receivers. They used a very standard type ISB detector system using the phantom type lock. How that worked, we had the receiver, which we'll have a more detailed diagram of. We had the carrier processor, which was essentially a very narrow band filter that converted from the IF of the receiver down to a very low frequency signal. They had the discriminator, which would just essentially form an AFC loop between the receiver, the local oscillator, which was injected into the receiver, and the thing would lock up on, theoretically, a pilot carrier that was transmitted from the transmitter. But, of course, in this system, there was no pilot carrier, so it essentially attempted to do a lock on the noise, and this made the whole thing coherent, essentially, based upon the noise. And then the output came to the ISB detector. You had the carrier injection. You had three of these channels with 6 outputs. This is a detail of how the receiver system worked. The basic receiver, the SP600, was a standard type receiver with a pre-selector RF amplifier mixer. The LO was switched out of the circuit. That was from a separate assembly. Had 2 IS sections, second mixer. And the BFO CW detector became a third mixer, supplied 25 kC. You can see the carrier processor had limiters and 20 hertz bandwidth filters and all that neat stuff, which is very much similar. Technology was used quite commonly in the 50s and 60s and the 40s to receive communication signal. They converted down to 2 kilohertz again, went through another limiter, went through a discriminator, very similar to what's in your FM radio. That's why we show the S-curve. That's how we show a discriminator. Went back into an FM reactance modulator to the LO stage, and this whole thing locked up. There was a 25 kilohertz crystal oscillator which supplied the carrier for the detector. The signal came out at 25 kilohertz, went through filters that were very closely matched for phase and frequency response, and provided two outputs. This was the first chair. They had problems with this chair inasmuch that this coil structure was open. It picked up from outside, as well as from inside. They had to locate this chair at Southampton, which was about 15 miles away from Montauk, so it wouldn't feed back to the transmitter. The thing would feed back, lock up, and cause all sorts of problems. So they had taken the output of the Cray 1 computer and microwave linked it over to Montauk. Of course, if you had any sort of little time glitch, reality glitch go through the microwave beam, this thing was spitting back information at such a rate that it sent the whole system into oscillations and caused all sorts of problems. So they came up with a second version of the chair. Okay, what we can do also is we'll show you the equipment that was used on the first version of the chair. This is a Hammerlin SP600 as modified by ITT. In fact, you can see ITT Worldwide Communications here. This is the back end of it. Anyone knows an SP600 can recognize that this module is different, this module is different, the layout of tubes in here is entirely different. This is the carrier oscillator. You can see Mackay radio, which became ITT. In fact, this piece actually came off the Montauk Air Force Base. You can see the rust on the tubes, because the Montauk Air Force Base was a very damp, rusty place. And you can see this technology is quite old. This is their carrier processor. There's the very narrow band filter. You can see this also came off the Montauk Air Force Base. Of course, the SP600 receiver I still use. These I don't use. In fact, I haven't even fired these things up because I'm a bit afraid to plug these things in. There might be a lot of smoke. This is the discriminator module. Of course, what's on it? ITT. I'm sorry. And this is the upper-lower sideband detector. Of course, what's on it? ITT. This is the back end of that with all the ancient tubes. You know, those are those glass encased FETs. This is essentially what the first chair system looked like. Now, based upon information they've gotten from crash UFOs and technology exchange, whatever, they found out that essentially you could put the victim between a set of Helmholtz coils. Helmholtz coils are interesting because they can be phased as such that the pickup would only be between all the coils and would exclude, to some extent, all the junk outside. Now, of course, if we go back, we're not going to do it here, to the pyramid antenna structure, this is something known as delta T or delta time sensing pickup type structure. This is one of the things the pyramid does. It does translate time waves. Now, of course, they had to get the delta time structure in the receiver. We'll go into that in a few minutes of how it was actually done. They used the exact same system, except they replaced the Hammerlin SP600 with an RCA receiver designed back in the mid-30s by a man known as Nikola Turbo, who really was Nikola Tesla. Nikola Tesla understood the delta time factor, and by placement of coils and such in the receiver, he replicated the pyramid factor, if you want to call it that, for those people who are not going to go through all the delta T factors and stuff like that. And they replicated the pyramid coil with the receiver. Of course, the block diagram is the same, except that the RCA receiver had different IF frequencies and all that nonsense, but we don't have to go into that here. You can see I have in parentheses the different IFs and the changes that they had for the receiver. This, of course, is a picture of the RCA receiver actually taken off the Montauk Air Force Base. Again, you can see the moisture damage. This particular one I haven't fired up. I fired up the others, which I've gotten out of RCA. They're in much better shape. As you can see, this one's missing a tuner. And if we go inside, we can see this thing was designed when Bob Butwick was a young man. And if we go to the back, let's go to the front. These things are each individual coil stages. This thing, they apparently, for some reason, didn't want to use a gang tuning cap. So each individual section of the preselector was an individually tuned network. They had separate tubes for each front end. This one's, of course, missing, and the local oscillator sat down here because this one was modified to use the remote local oscillator that was locked. So you can see that's all missing. They got two nice, neat little boxes here that do convert down to the IF module, which I don't have pictures of because it looks like this. And if we go to the back, we can see every element in the vacuum tube has its own coil that sits right under the big coil. Although there's a big metal plate, aluminum plate in here, there is a higher order relativistic psychic energy quantum coupling between these coils and the coil up above. That's your delta T function. This is one of the secrets that Nikola Tesla had learned, how to place these coils to get time manipulations within this part of the circuit here. You got the same thing here. You notice this is very symmetrically laid out. Of course, this is designed back when Bob here was a kid. Of course, they used the same carrier oscillator, the same carrier processor, and the rest of the 9 yards of the stuff. And this chair, since it was somewhat shielded, they placed this system in a room right under the transmitter building, right above the Delta T antenna that was buried. It was like 200 feet on the side. It looked like this over here, but you can get that later. And, of course, Mr. Cameron would sit in the chair. He would go into a trance, completely clear his mind. They would put a thought into his mind that they want transmitted, and he would think it. All this equipment would pick it up, process it through the computers. We now have a block diagram of the computer system. What's the first thing you see? 6 channels of A to D converters. Of course, there's no mystery here. I'm not going to go into what A to D converters do. That's analog to digital converters, 1 of 6, 6 of 6. The Cray 1 was the most advanced computer at the time. It had a 32-bit bus. They used a PDP-11 or a VAX-11 to interface to Cray 1. You couldn't talk to this thing direct. You had to use a smaller computer to talk to the bigger computer. Mr. Cray, he used his worldly wide wisdom to design a system like this. And they had all sorts of peripherals. With this, they could sit Mr. Cameron in the chair, go through the whole 9 yards. The algorithms in the Cray 1 would break down what he was thinking into audio, visual, direct visual representation. They could display it on a screen like this, what he was thinking. They could type out what he was thinking verbally on words on a what looked like an old teletype, a KSR-33 teletype. I think we all remember those things clanking away a million bits a minute, making tons of noise. Nobody liked to listen to things, so they stuck them in the corner somewhere. And what did this do? This spit it into another computer. This computer essentially was used for storage of the information, and also they had to remove the thought form matrix from the thought form that Mr. Cameron was generating and put on the matrix that represented the matrix of the transmitter. Remember, when you're requiring a human being or a technological device to transmit a thought form, the matrix of that thought form has to match the matrix of the transmitting agent, or else nothing's going to happen, baby. So this computer would go through all the digital codes, remove the signature of Mr. Cameron, and put on the signature of the key person that designed the transmitter, because that's the matrix that was in the transmitter. Remember, this equipment becomes a conscious being. This is psychotronics, a conscious being this equipment becomes. It has a consciousness of its own. And just as you reject a form that is not yours, the transmitter will also reject the form which is not it. So this computer reprocessed from Mr. Cameron's matrix or signature to the transmitter's matrix, which was the head design man on the station. This, of course, went to another console, which controlled this computer. It controlled whether it was stored on magnetic tape, whether a thought form was played back from magnetic tape. An IBM 360 had big magnetic tape. It wasn't until later on they got the disc packs, which are about yay by yay, but still they were magnetic. That took in double precision 16-bit bus. It generated a 16-bit signal. I'm sorry, this was 32-bit. It generated a 16-bit signal for this very specialized semi-analog digital computer designed by AIL, Division of Cutler-Hammer. Of course, I used to work for AIL, Division of Cutler-Hammer, and recently got laid off. And I went looking for information on this computer, and all the print numbers and such, they're listed on file, but there's no prints available, there's no titles listed at the number, they're listed as blank. Skip these numbers. That's quite interesting. And when I started to inquire, security went up like a rocket through the roof. You're not supposed to inquire about stuff like that. Well, the thing's saying, oh, Montauk Point. This thing will go from that end of the room to that end of the room. Lots and lots of vacuum tubes. The thing was a forest of 6080s. The thing had this huge big canister in it which had electrical acoustical quartz delay lines, which turned out to actually can generate a consciousness in those darn things. I still don't fully understand it. And 16 bits of data went out. We got 17 lines of individual pulse modulations. This is where we differ from a radar transmitter. Also, the transmitter controlled the antennas. What was going on with the antennas? Where it was pointed, when they were using the directional antenna, or it would switch to different phasings and the different dipoles on the big stick that had about 30 or 40 odd dipoles on it. I never could count them. I'm not going up on the top of that tower to count the dipoles on the antenna. I'm crazy, but not stupid. And we go back to the transmitter. Notice we've gone here, we've gone here, now we're going to go here. Notice they got two of these monsters. We got two of these 100 kilowatt transmitters. This is now a block diagram of the transmitter. The basic signal is essentially a heterodyne type setup. What's interesting about this is the Stalo, which is a huge chassis with 5 crystal oscillators on it, electronically switched, means they can switch to 5 different frequencies. This is important for the Levinson transform. That was a function where you could translate frequency deviations to time deviations. It was delta F with respect to delta T using differential equations and such, and I've seen the mathematics, and I don't want to go into it here. And we would multiply, go into this mixer. Now this one could either supply a CW signal or an FM signal. Of course, we have a massive synthesizer supplying the signals for this. They had multiple mixers. They came up here finally with 425 to 450 megahertz. Now, they talk of synchrodynes. That name is right off the block diagram that's carried out personally by Preston from Montauk in '86. I found out what the synchrodyne concept is. In the initial transmitter, these frequency source was left continuously on, and this thing was pulsed synchronously, so either a lot of amplifier stages, or it would be enough gain to supply 1,400 watts of pulse power from probably maybe 1 watt here of pulse power. And it would be high isolation off, high gain on. And that's all they did in the basic SAGE radar transmitter. Except this group of nuts, what they did, they came along, they pulsed the mixers, and they pulsed each one of these stages individually. And I have recollections of going through pulse modulations and such, and they might pulse this one on, pulse this one on. It was a real crazy, odd setup for the way they pulsed these different stages on and off. What they're actually doing was loading a thought form here, shifting it to here, shifting it to here, loading more, shifting it, loading, maybe shifting it backwards, loading more. And they built up the esoteric function as the esoteric function bounced around in all these stages in the whole transmitter. Now, another aspect of this is what we have here. We have a noise source. This is a white noise source synchronized by Mr. Nichols Tesla's whirligig zero-time reference, which I'm not going to go into here. And they use this noise to essentially pulse noise modulate the Stalo, pulse noise modulate the outputs of the synthesizer, which means you ended up here with a carrier with white noise modulation on it. if you go through your signal processing, you'll find out that white noise is 50% correlated to anything and everything within its bandwidth. That's right out of college, people. That's in your college textbooks. Look it up, it's in there. Which means this signal now is coherent to itself, and it's also coherent to hyperspatial functions, because white noise essentially comes out of hyperspatial functions. If anyone wants to debate that, I'll debate that with you later. And of course, they had their zero-time reference, which synchronized the white noise function. So at this point, they started to build the thought form within the pulsed signal. Of course, there's still no output here. They then split it and sent it to the other transmitter. The other transmitter was just this group here. You know, the pulse modulators and the 3 IPAs and the P8. At that point, it went into this IPA number 1, boosted to 7 kilowatts, went to IPA number 2, boosted to 75 kilowatts, went to IPA 3, boosted to a megawatt, went to the final amplifier, which is a first cousin to a magnetron known as an amplitron, which is essentially a backward, slow-moving wave structure oscillator, which anyone's interested in, I can explain that to you what it does later. And goes through different isolations, goes through the band-limiting filter, so this thing doesn't spread to hell and gone and back and wipe out every TV on Long Island and wipe out every radio on Long Island. You know, this thing spread as far and wide. And then they produced 12 megawatts here. They lost a megawatt in the isolator. It means you have to water cool this. They lost another megawatt in this filter. That was water cooled. And if you look in the Montauk station, you'll still see all the water cooling equipment in the antenna room for these. And it went out to the antenna. Of course, these stages are individually pulse modulated also. So we had 14 pulse modulation points in this transmitter. Of course, the human lattice structure is based on 7s, 14s, or 21s. It's the magic number 7 again. And they built the thought form by pulsing all these stages, and they did some weird ways of pulsing. This is essentially how the transmitter actually worked. As I said, I'm not going to go into very deep technical detail here. Anyone interested in it can see me later, and we can go much deeper into technicalities of this. I'm trying to give you people an overview of what this did. You can get the tape and the paper, and this will all be in it, and you can study the block diagram and such. What we have here, pictures again. That's the stalo. I apologize, it's a terrible picture. The camera went kaflooey. This is the best of the 2 pictures I was able to take. This is 5 channels of crystal oscillators, multipliers, summer, other amplifiers. This chassis multiplies it, and this is their noise source chassis. You can see this noise source essentially is a noise tube fed into a very wideband, high-gain IF strip, and at this point you got tons of noise. The bandwidth on this is maybe about 10 megahertz. And all this stuff here was the synchronization from the 30 hertz sine wave they put into that port there, and they took the noise out of a port here. This, of course, is the synthesizer that drove this, which is the FM oscillator, and this is the first mixer in the system. Use a power stage at 101 megahertz, and this thing provided all the frequencies for this oscillator and all that other good nonsense. This also was modulated by the white noise source, and this chassis also, one of these stages, is pulsed by the white noise source. It's right there. There's one of these ports over here that goes through amplifiers here that pulses these. But these tubes, if you look closely, not in this picture, you'll see these tubes are added later. And they just pulse one of these amplifiers. Remember, this frequency generator chain was essentially in the old stage transmitter on continuously. They used a synchrodyne to get the on-off effect. Because when you start up a crystal oscillator, it starts, smooths up the frequency and stays there. They wanted to be able to pull out a pulse which was exactly on frequency at all times, and switch from one pulse, one frequency to another frequency, and always be on frequency. So all these oscillators here And these crystal oscillators here had to be up and running continuously. And they had trouble with phasing and such as the different mixers came up, so the whole RF generator chain was on constantly. Although this mixer in the Montauk project was pulsed. They didn't care about the phase, apparently. This is your final mixer. This, of course, has a 3CX100A5 tube in it, which some may recognize as a 2C39 from World War II. That's that nice little White House triode that puts out 100 watts. Then we go back to our block diagram. We now will look at the synchrodyne. This is 8 stages, each one 3CX100A5s or 2C39s. And voila, there they are. 1, 2, 3, 4, 5, 6, 7, 8. People, they had these nice, expensive ceramic iMac triodes in here. You can see where they blew air through them. Each one of these has an air input and an air output. And this thing sat there, and this built up at least 50% of the thought form in these boxes. These are cavities. You know, TEM mode cavities. These darn things. Now, these were 7214 Ceramo-Wax pentos, which are about that big around and about yay tall, had rings on the bottom for the electrodes. These sat in cavities about yay long and about yay square, and had huge fans blowing them. They had 2 of these. This thing, this tube is 6952, looks like a robot. That tube is about yay big around, has a round section like a flying saucer, about yay thick. It has things sitting down that you connect to it. It has 2 legs sitting down for the water cooling, 2 legs going up for the water cooling. It has the plate on top, and the thing actually looked like a robot. That was this stage here. That thing put out either 50 kilowatts CW or a megawatt of pulse power. That's a lot of power, people. This, of course, was waveguide at this point. You'll put this into a coax cable. You've got so much voltage in the coax cable, you get any of Albeelec's standing waves. Of course, they're not Albeelec's standing waves. Folks, that's right out of your college textbooks. That's out of your tech school textbooks. If you had a standing wave problem, you could sit and watch your coax cable explode. I think we've all seen coax cables explode from SWR. That drove this big thing, which we'll have pictures of later. All these stages were removed from the Montauk site. I'd love to know what they did to these stages. This is one of the things we don't have. We're assuming that these stages look like these stages, just bigger. I'm not sure. Because both screen rooms that had all these stages in them were gone. Screen rooms there's nothing in them. They went to the Amplitron, they put in 600 kilowatts of power, got out 12 megawatts of power. I already went through this. And they provided a signal to the antenna. This is a picture of the power supply. This is the power transformer. If we can focus it a little. Three-phase input, 3-phase 20 kV coming out here. This thing I'd love to put on Bob's back. This is one of the Amplitrons, one of the Thyratrons. They use 4 of these monsters in parallel. This is a 66 megawatt pulsed Thyratron, a hydrogen Thyratron. The whole thing sits about that tall from the floor. The tube itself is about that big around. They had a cabinet with 4 of these, boom, 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 hooked up in parallel. We went to the pulse network that Mr. Bielek described. This is the Amplitron. Of course, you can see where the welding was done, the cutting to cut the transmitter apart. You can see some welding marks here. This thing, the tube sits from here. You can see the cooling. And it sits right down into about here, inside of an oil bath. The pulse transformer is down in here. As Al said, they already had capacitor networks. Each network had 5 capacitors. They had 3 groups of 5 capacitors in the network, 15 capacitors they used totally. It was a typical type pulse delay line, with inductors in series and capacitors for ground. They charged up the caps and then shorted the one end of the line and dumped the other end into the pulse coil. So much for the transmitter. This is a picture of the building this transmitter sat in. This is a 100-foot by 150-foot tall tomb or a monolith from 2001. You can see some of the antenna up there. And this is the 2 floors. You can see some cooling that the transmitter sat on. They had cooling towers standing outside this thing. They had a field of whole pig transformers sitting next to it. They fed this thing with over 2 megawatts of power. The generators in the power station, they were pumping at least 2¼ megawatts into this thing. I'd love to know where all the heat went. Must have got hot around there. I really remember it was hot. We're now going to discuss the antennas. Can we focus again? The first diagram I made said overall blotch diagram. So I had to fix it. Whoops. Great. I fixed it, the block diagram. They had 3 antennas at Montauk. They had 2 above ground antennas and the delta T antenna below ground. What they actually did was they used the reflector to reflect out away from the subject the burning rays, the microwave oven rays. The etheric component, being it doesn't know any solid matter, passed right through the reflector, and essentially the etherics went out parallel with the gain horn feed, as the gain horn would send it. They had this big monster waveguide switch to drive either the omnidirectional antenna or the directional antenna. They also sampled the pulse from the final pulse-forming network and fed it into the windings of a delta T antenna. What is a delta T antenna? Let's now look over here. This is a delta T antenna. How do you make a delta T antenna? It's easy. You wind a loop diamond shape on x-axis. You wind another loop at 90 degrees to it, diamond shape on the y-axis. And you wind a third loop, diamond shape, around the perimeter of this thing. What does this thing look like? Here up is one pyramid. Here down is another pyramid. This is 2 pyramids, base to base, one pointing up, one pointing down. You build up a thought form in here with the XY loops using the correlated white noise that will grab the thought form and rotate it. It will spin it into a cylinder, and as that cylinder is rotating, it has to bend time to get the rotation. It means now you're generating ricklets of time coming off this rotating cylinder, and this is a time vortex, as talked of in quantum electrodynamics. So as this thing spins, the imaginary cylinder in here spins, or it's called a spinner in physics, and sends out a field of time waves. All right, let's go back to our picture. And again, they take the output of the noise source from our transmitter, put it into a 100 kilowatt audio amplifier. Boy, I'd love to have that one, people. But they took that one with them. I would have got that out if I could have. They took that one with them for some reason. That went into the horizontal coil. And the 2 pulse modulations from the final network went into the X and Y coil. Now, by feeding RF into the omnidirectional antenna and feeding the baseband into this magnetic antenna buried underground, this was the same function that they had on the Eldridge. The Eldridge, remember, had an antenna on the top of the mast and magnetic coils on the base. So this, of course, was much more tighter controlled. Here is a picture of the directional antenna. Here is a picture of the cherry stick on the back, which is the omnidirectional antenna. Can we focus it? We can see a lot of 2-inch coax cables going into this thing. There's a phase array box. There's all sorts of relays in there. I wasn't brave enough to go get those out. Or to go up here and take this. That's still there. And you can see dipoles. There's 3 on each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 36 dipoles was in this big cherry stick. Of course, we have a picture of the Delta T antenna for the videotape. Now, we have a demonstration here. This is my own edition of the Montauk system. The CD player, or the mind amp source. You can find out information on the mind amp by looking at tapes from the Chicago conference, or you can get my paper on the BioFist, which explains the mind amp. The quantum correlator is essentially an analog computer that correlates the ones and zeros. It goes to the amplifier chain, drives the XY coil. Then we have a noise source going to the Z amplifier, driving the Z coil. Now, this is very quickly our surplus store. So much for that. Now let's have our demonstration, the fun part. I'd like to have 4 volunteers from the audience to come up and just sense, get a feeling of what this is doing. Yes, ma'am. You won't disappear into hyperspace. What I have is I have a picture here. I'm not going to show you the picture. I'm going to sit it in the small mind amplifier. This is a quadrature function that goes this way, just like the chair is. The output of this goes to the computer. Here's the noise source, goes to the amplifier. The noise source goes to this amplifier, goes to the antenna. What's here is being transmitted here. You all of a sudden may notice, how many people notice like a cooling, a sudden cooling in the room? That's from this. Now, I'd like you people to just essentially close your eyes and tell me where you feel you would be standing right now if you weren't in this room, based upon what you're feeling. You're feeling something unusual from this. Everybody in the audience, I think, is beginning to feel the cooling. Okay, man, where do you think you would be?
Standing at a table, you're sleeping at a table or something like that.
Okay, sir, what do you...
Same place I am right now.
Okay, sir.
Preston media is driving in a car somewhere.
And you, ma'am?
In the field.
In the field. What's in the field?
Grass.
What else do you pick up?
Trees.
Yep. What else?
Plants.
Mm-hmm. What else?
Dirt.
Yep. What else?
Rocks.
Yeah. What else? All right. I'll now show you the picture. Somebody said water in the audience. Here, can we get it on camera so everybody can see it? We have a woodland scene with trees and a babbling brook. We have a woodland scene with trees and a babbling brook. This lovely lady picked up the thought form being transmitted. And I can tell you honestly, there's no collusion between any of us. It doesn't mean you people are no good. It just means she has a more open psychic sense. That finishes the lecture demonstration. Let's now go to question and answers. You got it on the camera, good stuff? How are we doing on time? 5 minutes, okay. Yes.
Could it matter what angle the person stood in relation to the antenna and its various...
Theoretically not, but remember, this is not ideal conditions, so it could be. Okay.
I have a question here. You talked about quantum coupling between the two coils in the chair. How does that relate to what Bearden has been telling us about scalar electromagnetics?
Well, Bearden, when he talks of scalar electromagnetics, is essentially what I call a potential wave. It's there, but it's not there. I believe that definitely couples into that, definitely.
That is, we're talking, this thing is a scalar generator or a detector, or both?
That term, scalar.
Well, I mean, I use that term because of our,
Scalar has become a catch-all for anything that's non-Hertzian. It's a non-Hertzian pickup.
Preston, anybody sitting in the chair, would they have an experience of time travel or anything like that happen to them? That's the first thing. And the second question is, were there the future scientists that our previous speaker spoke about, do you know who they are by name or occupation?
Yes, but I can't say.
Well, in the first question then, people sitting in the chair with
remember, the person sitting in the chair was deeply, deeply entranced. His conscious mind was deferred and pulled off to who knows where inside himself. And the primitive mind was allowed to surface, which is a very flexible, pliable function. Yes, Alan?
Yeah. Could you please describe the design of the amplifiers, the three amplifiers, and...
Leave it to an audio man to ask about the amplifiers. Do I have something to write with? It's a very interesting design. It's what's called a distributed line amplifier. This is a design that goes back to the year 2, this amplifier. What it is, it's essentially a delay line, a coil, with capacitors to ground. I'm going to show you a 3-section version. They terminate the line, put in the signal, and then you have 3 amplifier stages. This is an old-style way of getting broadband amplification. I read a number of descriptions that describe this line as differentiating with frequency, and the one closest is either the highest or lowest of the band, and the next one is the next part of the band, and you got another part of the band. Of course, what do? They sum this thing the same way. Output with the capacitors. This is what's called a distributed line amplifier. Now, the interesting point on this is essentially all these amplifier stages, and those amplifiers is 10 of these, 5 groups of push-pull. They essentially, electrically, have the gain of the amplifier, the voltage gain of the amplifier, but etherically, these things add on a real strange, screwy setup. So this amplifier has more etheric gain than it has electrical gain. Another question?
Yes, by doing this time travel experiment and by going back into the past, if you made a change and caused another reality, how would you know at this time frame if you made a change?
Which came first, the chicken or the egg? Can you answer that? No, we can't answer that. We don't know. It's the same as the chicken and the egg. I'm not trying to put you down, man. It's just, if you change the past, you're going to change the future. You know what's happened in the future based upon what you did in the past, so you're probably not going to know what happened. It's going to be one of these closed loops where whatever happened between you and the future and you and the past becomes a separate reality, is separated off the timeline. Watch Back to the Future. It's a very childish movie, but some of the time concepts are quite accurate. Yes?
No more questions? That's it. Okay, thank you.
I'll be around to answer more questions.
Get out.